Hello, my name is Bennett Bridgman, and today our group will be telling you about the carbon cycle. The carbon cycle is extremely important. Carbon is found in all living organisms, in rocks, water, and air. Carbon's involvement in the hydrosphere, geosphere, and atmosphere is extremely important, as it's stored and transferred between all of them. John, Dallas, and Michael will tell you more.
Earth's oceans play a vital role in the carbon cycle. They are far and away the largest carbon sink on the planet, and nearly 50% of atmospheric CO2 produced by the burning of fossil fuels has ended up here. Through many complex chemical and physical processes, carbon is transformed, transported, and stored within our oceans, serving as the critical link between the atmosphere and the geosphere. To better understand this link, let's illustrate the processes occurring here. Atmospheric CO2 is dissolved into shallow surface waters, where, depending on the water temperature and the presence of marine life, it will either sink to become part of the deep ocean carbon conveyor belt or be incorporated into marine organisms. If the CO2 becomes part of the deep ocean carbon conveyor belt, it will be transported for hundreds of years before resurfacing at warmer waters and evaporating back into the atmosphere. If the CO2 is incorporated into marine organisms, it can be used as fuel for photosynthesis or as the structural building blocks for shells and corals. When these organisms die, they sink to the ocean floor in deposits of carbon-rich sediment and form the carbonate platforms found all over the world today, which are responsible for storing carbon for millions of years.
The atmosphere plays an important, major role in the carbon cycle as it is a major reservoir and it holds approximately 720 gigatons of carbon. It also plays an important role in the greenhouse gas effect as atmospheric CO2 is released through various processes over the land and the oceans.
So now we're going to talk about the geologic side of the carbon cycle, and an easy example is shown right here. Carbon starts out being released into the atmosphere from volcanic eruptions and gas seeps. It then builds up in the atmosphere and eventually precipitates as acid rain, causing chemical weathering on the rocks below. These rocks absorb the CO2 as they weather from this precipitation. The carbonate sediment formed this way is washed into the ocean, where it forms into fossil fuels and different carbonate rocks. These are then subducted from geologic activity and are heated into the magma for more volcanic activity, therefore restarting the cycle.
Thank you for your attention, and we hope you've learned more about the carbon cycle and its interaction between the Earth systems.